to Kirkham. So accelerating from rest at constant acceleration. So what we need to do is use so we've got S equals ut plus half at squared. Can I make that a bit smaller? Oops. That's better. So use S equals ut for both. That thing in the background's the OPC mining Bitcoin. And obviously, so we're going to do that for like displacement 1 and time 1. And then we're going to do it the same thing for, well, I'm going to tell you in a sec. So what we're going to do is figure out how far it goes in the first second as well. So then we can get the total distance travelled in 2 seconds. Once we've done that, we can figure out acceleration. So the accelerations are the same. So, and the initial speed in both instances is obviously 0. So rearrange to find A. So that's going to be 2s over t squared. So 2 lots of distance 2 over t squared. Now distance 2 is going to be the distance travelled in 2 seconds. So that's going to be 2 times the distance. So the distance travelled in the full 2 seconds is the distance travelled in the first second, which is S1, plus the 15 metres that we're covering in the second. Alright. And then we're going to divide that by t squared, but 2 squared is 4. Alright. So then we're going to do the exact same for the first second. Now the first second is going to be 2s, or 2 lots of S1, over 1 squared, which is obviously 1. Then let's multiply these out, find S. So S1 is the distance travelled in 1 second. So we've got 2 lots of S1 plus 30. So 2S1 plus 30 equals, then we've got 2S1 over 1. So we're going to do 2S1 times that 4 through, so that'll be 8 lots of S1. So distance 1 is simply, so you've got 8S1 minus 2S1, which is 6S1. So it'd be 30 divided by 6, which is 5 metres. So now we've got the total distance travelled in the first 2 seconds is 20 metres. So now we can figure out acceleration. So now I'm going to write SU that, obviously taking right as positive or whatever. So the total displacement is 20 metres. So we've got the 5 metres plus the 15 metres in the second. Initial speed 0, final speed not interested, acceleration is what we're figuring out, times 2 seconds. So that's just S equals ut plus half at squared. And then obviously use 0. So rearrange to find the acceleration, so it's 2s over t squared, so 2s is 40, and divided by 2 squared is 4. So the acceleration is 10 metres per second squared. Now we can figure out how far it travels in 4 seconds, how far it travels in 5 seconds, and subtract them. I know it's a bit long-winded, but so we're 10 metres per second squared. You can rewind that if you need it. So let's do solve that again. So the displacement is what we're looking for. The initial speed 0, final speed not bothered, acceleration's 10 metres per second squared, and the time, so we're going to do 5 seconds and 4 seconds. So let's do 5 seconds first. So it's S equals ut plus half at squared, but use 0, so it's S equals half at squared. Half of A is 5, so the displacement is simply 5 times, you've got 5 squared and 4 squared. So the 5 squared is 25. So that's how far it travels. So 25 times 5 is 125 metres in the full 5 seconds. And then let's do 5 times 4 squared, which is 16. 5 times 16 is 80 metres. So that's in 5 seconds and 4 seconds. So in the 5th second would be 125 minus 80. Which is 45 metres. Hopefully that's alright.